let's say we have an arbitrary graph like this one, and this is say y is equal to function of x. Now this graph from any point x1, and this is another x2, so let's say there's a situation when this one is rotated about the x-axis, so like that. So what happens if this graph is revolved around x-axis is we will get something like this. It will revolve around this one, so I will just use another color maybe. So it's revolving like that, essentially it's revolving, so we will get a shape like that, of course, which will be, we can appreciate that we will get something like this. So we need to find the volume that is generated because of this rotation. So if we want to do that, let's say this is the point x1, so we take a very small section which goes just little, another one, does this much, we take many sections like this. So this section is, we go back to black again, so this one is x here, and this is just x plus a very small increase del x. So this is so small that we can say that the y is nearly the same because it's very small. So what we get now is, we can see we get something like a very cylinder, a cylindrical. So if I will just exaggerate the diagram so that we can analyze it, we get a cylinder where this one is the radius, the y will be the radius, and this is just del x because that's the difference. So we get the area, the volume is becoming, we know the area of the volume of a cylinder is pi r square h. So here r is the radius, which is y square, and h is of course del x. So if we add up all these small cylinders, we get the entire volume. So we will get like pi, say y1 square del x plus pi y2 square, so let's say call it del x1, y2 square del x2. If we take another one, let's say this one is del x, or we can say like all the sections are, so del x1 is equal to del x2, everything is like all these small rectangles are of same height, or you can say just like that, not rectangle, the cylindrical cylinder, the height will be same, so del x there. So if we add all them up, we can appreciate we will get the entire volume. So it's like summation of pi here y square del x, we will get, if we sum up all the del x, we will get the total volume. Now if we make this del x very infinitesimally small, we get this summation is replaced by an integration, and we get like that. So this is the volume that can be generated, that can be found from calculus for this kind of rotation. Similarly, you can do another one. I will just go into the other page, and let's say we have the same graph here, and it is now, instead of it being rotated across the x-axis, it is now rotated across the about the y-axis, so maybe from here to here, and we get the same thing. We will get like something like that, and our thing will be like that, and again this time our radius is becoming the x here, and the small heights will be del y. And again, if we add all those small cylinders, we will get that entire volume, which again will become pi, and the radius is now x square because radius is x, and then dy. So we have to remember that when we are rotating about x-axis like the previous one, we are getting del x. It will be, the integration will be, the variable will be del x. So we will have to express the y in terms of x. From the given function y is equal to fx, we have to express the y in terms of x. Similarly, when it is rotated about the y-axis, we have to integrate about del dy, and we have to express the x y in terms of x. So if we have, say, let's say we have something y square is equal to x, just arbitrarily speaking, so we have to write x square, whatever is x square there. So if y square is equal to x, x square is equal to y to the power 4. So we have to write like that. So this is how we will have to do the integration, del y, sorry. So yeah.